And guys, so as I said, we're going to try and answer G, which is basically we need to do the same process that we did with part B for Tn. Okay, so here's the, just let me clear some space. Here's the process, and it is pretty brutal. Okay, you're going to use integration by parts again. So you're going to do T of n is equal to the integral between pi over 4 and 0 of this time tan squared x times tan to the power of n minus 2 x with respect to x. Okay? And so now what you're going to do is you're going to change this, because you've got to use that identity that the clue is in the question, to this 1 minus sec. Sorry, no, it's not. Got it wrong, haven't I? Let me just double check what the question says. It's sec squared x minus 1. Tan squared x equals sec squared x minus 1. So we're going to get, sec squared x minus 1 of tan to the power of n minus 2x with respect to x. Okay, which equals the integral between pi over 4 and 0 of sec squared x tan to the power of n minus 2x minus also the integral between there of tan of n minus 2 to the power of x. We actually don't need to use integration by parts this time, because these are actually quite easy to integrate. Okay, what we've got so far. Certainly this is Tn. This actually is t of n minus 2. Okay, so I can just change that. That's what it is. Okay, and this piece here I can actually integrate, because I can do it by substitution, because the differential of tan x is sec squared x. So let's just do it over here. So we've got sec squared x tan of n minus 2 to the x with respect to x. So I'm going to let u equal tan x, then du dx is equal to sec squared x, and so dx du is equal to 1 over sec squared x. So it will become sec squared x times u to the power of n minus 2 dx, employ the little trick, du, and now you can see that the sec squareds will cancel. Oops. So I'm left with u to the n minus 2 du, which is equal to 1 over n minus 2 u to the n minus 1. Okay, which is equal to 1 over n minus 2 tan to the n minus 1 of x, okay, minus t times n minus 2. Okay, so, and that has to be between pi over 4 and 0. Okay, now tan of pi over 4 is equal to 1. So 1 to any power is also going to be equal to 1. So, hang on, what have I done here? Sorry, that's a mistake. That should be n minus 1. Okay, it should be n minus 1, not n minus 2. n minus 1. Okay, I did my integration here wrong. This bit here is always going to be equal to 1 if it's pi over 4, and it's always going to be equal to 0 if it's 0. So basically, you're ending up with 1 over n minus 1 minus Tn minus 2. And there is your answer. Because of the step you need to take here and the difficulty in integrating that, I think that you probably won't get those marks. But, you know, maybe you're a miracle and you can do it. Where was the condition n must be greater than or equal to 2? Well, very similar to the other part. We need to make sure that this is positive or it all goes to mush and doesn't work anymore. Okay? So, that's it. Very, very tough, but by being strategic and not fussing yourself too much about getting 100%, you can do well on this. You've got to cherry pick it. Read the questions carefully, decide what questions are really easy, and the questions that are tough, maybe leave them, go back to them, do them at the end. Okay, and then whatever you can pick up for those tough questions, that's just going to be a bonus. All right, let me know if there's any of that you didn't